So, very good morning to all. So, we will continue machine tool gearbox aspect, particularly the ray diagram aspect. So, this another diagram, you can see the ray diagram. So, by looking at it, one is the initial construction is given. This is the initial construction ray diagram. The other one is a complete diagram. Okay, if you look at from the ray diagram, what information we can get. The first thing is the structural formula. If you look at very carefully, so you have from here, if I, from the observation, this is your input speed, right? It goes to the up to this position. Then after that, this you will have a, this is the beginning of a first stage. From there, the speed is split into two. Then you have two outputs in this point. Then you have a three speeds. You can see that three speeds you have output speed to the second stage. From there again you will go to two output speeds in third stage. So, maybe I will read it here. This is the first stage, second stage and third stage. Okay. So, usually when you do the ray diagram, we always focus only about the gears arrangement. We are not considering about the input aspect. So, we can ignore this aspect. So, from here if you look at, I can straight away write 2 output speed, 2 of 1, okay. Then 3 output speed in the second stage. So, 3 of 2 input from first stage, then finally, right. So, you have 2 outputs, okay, 2 should be 6. This is the structural formula, you can see that, yeah. So, that is observation, you can make it out. So, and also as I said earlier, it has to follow the optimization aspect, particularly the I max and I minimum aspect. So, for except first stage, all other stages should have the ratio, gear ratio I max, N max, N input speed should be less than 2, okay. That is one thing. And another thing is gear ratio, for minimum gear ratio M I mini, your minimum speed, okay, and input speed greater than 1 by 4. These two thumb rules should follow. Apart from, always your N max greater than or equal to N input, right, then your N minimum. So, we have to follow these thumb rules during construction of ray diagram, okay. This is applicable all the stages except first stage, except first stage, it will not be applied, okay, except first stage, yeah, that is what happened, okay. And also I need to give one more information, and if you could look at, as aware of that, each the vertical position indicate about the step ratio in logarithmic format, log pi, right. And in fact, if you look at this vertical thing, it is indicate about the shaft. So, in fact, this should be a input shaft and this should be your output shaft. In between you have a intermediate shafts. So, in a 3 stage gearbox, you will have a 4 shafts, because it has to maintain the center distance based, right. One stage means at least 2 shafts should be there, second stage 3 shafts, third stage 4 shafts, that is the arrangement. Interestingly, you can see that the speeds are arranged in a step ratio manner, okay. And also you are aware of step ratio is nothing but the how much you want increment or decrement speed from one stage to another stage, right. irrespective of the arrangement. That has to be maintained. And clearly, if you look at the horizontal lines, pi is given. So, 45 to when you take the ratio between 45 to 31.5 RPM should be step ratio of 5. Okay. So, that has to be maintained. Not only that, even if the lines are connected as a parallel, look at this. I'll take you one example. So, in this position and this position. So, this you say 31.5 is a speed, is a minimum speed, and if you draw the line and parallelly. So, what is your observation? Do you think these adjacent speeds are the maintaining step ratio, right? Okay. So, and not only that, and if you look at between 355 and 250, and we are aware of that 355 divided by 250 as a step ratio, but if they connected parallelly, still the step ratio is maintained. So, clearly you can understand whether the lines horizontal wise, vertical wise or inclined wise, if they are parallel, the step ratio will remain same. Okay. So, that is how the ray diagram is constructed. In fact, by doing the problem, we will understand even more better. So, shafts are shown by vertical equidistance and parallel lines. The speeds are plotted vertical on a log scale with the log phi as a unit. The transmission engaged at definite speeds of driving and driven shaft are shown on the diagram by rays connecting the points and the shaft lines representing the speeds. That is how the ray diagram is constructed. So, let us move on to the problem. We will solve one problem. Okay, it is an interesting problem. At 12 speed gearbox, the speeds available at the spindles are given 31.5, 45, 63, 90, 125, 180, 250, 355, 500 and so on, a maximum of 1410 RPM. The preferred suction formula is given 2 of 1, 3 of 2, 2 of 6. Using the ray diagram, determine the specific values of all transmission ratio and the speeds of all the shafts in drive. Also, construct a kinematic diagram and indicating the number of speeds, also construct kinematic diagram and indicating the number of teeth on the each gear. The gearbox receives 5 kilowatt from an electric motor running at 1500 RPM. That is the problem. Okay. So, in this problem what we have to do? We have to construct a ray diagram. That is the first part of the problem. Later we need to, based on the ray diagram, we need to construct kinematic diagram. That is the second part. The third part is we need to identify the number of teeth of each gear in the gearbox, right. The 3 stages we are going to solve. The first will focus about construction of ray diagram, right. And prior to that, I need to give information again for your better understanding. Remember, I gave a 3 ratios, right, the 3 thumb rules, n max, that should be follow, n max, n minimum, n input less than 2, okay, and one more, n minimum, n input speed greater than, less than or equal to 2 and greater than 1 by 4, and n max greater than or equal to n input again n minimum. This needs to be followed all stages except the first stage. Okay. That clearly says in the first stage, okay, already you know the ray diagram. So, I am just going to tell you how to do that. Okay. This is my smaller area, okay, smaller portion I am taking, assuming that this is input speed it's a input speed, n input. Okay. Yeah, this is the input speed. So, the first stage you can have gear reduction in this manner. Okay. And the another possible possibility, again you take this as your input and speed n input, then you can have reduction of the same speed from input to output, fine, and also you can do the arrangement in this manner. Okay. Then there is a third option, is your input speed, right? This is input speed, and what you could do, you can have the same speed of your input speed, but you do not want to have a higher speed. The purpose of the gearbox itself is speed reduction, right. At the beginning itself you do not want to have this type of a combination. This is possible, you can do that, this also, but not this one. That was the reason we have clearly mentioned these 1, thumb rule 2, 3 are applicable all the stages except first stage. Okay. And for other stages, so the combination can be many ways. I am just giving a few important. So, this is your input speed and these are output speed. So, you can do this way. Another way also, you can have same speed as input speed for the output and also even higher than the input speed. So, these things possible in other stages, but not applicable to the first stage aspect. Yeah. So, now we will take the problem. So, we can see that the instruction clearly given, the data, from the data we are able to understand that it is a 12 speed gearbox and the preferred structural formula is given 2 of 1, 3 of 2, 2 of 6. Okay. And also we have 31.5 rpm is the minimum speed and 1410 rpm as the maximum speed. Let us solve the problem. So, the data given is a 12 speed gearbox. Okay. Then the structural formula, it is already they are given. So, we are not going to use the optimum one. Structural formula given 2 of 1, 3 of 2 and 2 of 6. So, this is your third stage, this is your second stage and this is your first stage. Okay. 3 stages already is given. N minimum from the information what we got is 31.5 rpm. And N max is 1410 rpm. Okay. And the motor speed is given 1500 rpm. Okay. So, tell us what is the step ratio? Step ratio will take the from the ray diagram, from not only from the radar, from the given problem, maximum speed is 1410. The next adjacent speed is given as a 1000 rpm. If you look at this, is the step ratio comes as a 1.41. Do you think the step ratio is a standard one? It's not standard one. Okay. And if you refer the preferred series aspect, right, this falls multiplication of 2 series. If you take R10 series and multiply with the R20, okay, you would expect 1.41. Let's say for R10 is a, please refer the table, 1.26 step ratio. For R20 obviously as the series number increasing, a step ratio it decrease, that you know that. 1.12, if you multiply that you would expect 1.41. So this gearbox is the combination of two series R10 and R20. Okay. Now we will solve these given the speeds based on the speed for constructing the ray diagram aspect. Okay. So as you are aware of that, this is the ray diagram. It has 12 speeds clearly given. This is your minimum speed 31.5 rpm and this is your maximum speed 1410 rpm. Okay, that's clearly given. And also we have to rewrite the step ratio structural formula 2 of 1, 3 of 2, okay, and 2 of 6. So the important thing is, when you consider the ray diagram, it is good practice always start with the minimum speed. If you do that, then it is easier to go up to the other stages from third to second, second to first stage. If you start with the first stage, what happen? It will be cumbersome, it will be lot of overlapping and unnecessary time consume also. So to avoid that, right, what we should do that, we will always start with the lowest speed is given in the gearbox. Start with the lowest speed, then move forward to the first stage. If you do that, it will be much easier. Okay. Now we will take the ray diagram, okay, and look at, we had to follow the same the thumb rule, the I max, the ratio, gear ratio, the maximum gear ratio and the minimum gear ratio, these two we had to follow. Okay. And from here what we could see, okay, the right, already we have the minimum speed 31.5 rpm clearly given and the 1400 is a maximum speed is given. So what we need to do, from there we need to construct the ray diagram aspect. Okay. So if you look at from the given the structural formula, we keep using multiple times 2 of 1, 3 of 2 and 2 of 6. So this is the one we are going to focus now, is a third stage. Okay. So what is indicate 2 of 6? 2 of 6 indicate you have, right, 6 output speed, isn't it? 6 output speed and from the formula you have a 2 input speed. Okay, that's fine, right. For 1 input speed, how many output speed we would expect? For 1 input speed you should get a 2 output speed. I am not saying which speed, but let us say 1 output speed, sorry, 1 input speed should give, should have 2 output speed based on the structural formula. Okay. So if you follow that, so I fix it, this is the one point, right, this is the one point. What will be the next output? So now we are fixing the output, we are moving from the output of the last stage to the input of the same state, then move on. Okay. I fix the lowest one. Okay. What is the next output speed? It will be, remember the 2 of 6, right. So the another information what you get, the output speed of this one given stage should be 6 indicate 6 steps away, 6 steps away. That means if you look at 45, 63, 90, 125, 80 and 150, 250. So, we will have 6 speeds away from the lowest speed. Okay. So, if I look at the 250 will be the thing, these are the 2 points. Okay. Clearly I have mentioned this formula is given 2 of 6. So, one output should place, right. So, when you have one input you will get 2 output, the 2 outputs should be placed apart 6 speeds. That is another information you are getting from the structural formula. Okay. That you can see this is one point, this is another point. Okay. That indicate, right, that indicate. So, I have my minimum speed is n minimum 31.5 rpm, n max each indicate 250 rpm. So, I need to find out what would be the input speed for the third stage, right. So, what are the possible you would expect the input speed? What are the possible ways? Okay. So, when you talk about what are the possible ways, so we can do the trial and error method, because we do not know, we do not know. So, we will start with the first trial, we will start with the first trial. The trial 1, I will choose my n input speed, n input, let use n input as a 180 rpm. Okay, I will choose n input as a 180 rpm. So, can we solve it? Right? Can we solve? Can you solve it, please? Yeah. So, follow the n max by n minimum. What is the max? 250. Your input will be 180. So, that should give how much I should get? 1.38, which is less than 2, right, which is less than 2, that is correct. Okay, fine. Now, if I do, then now I had to go for the minimum aspect, is not it? Yeah. So, when you do the minimum aspect 31.5 divided by 180, it gives me 0.175, which is less than 1 by 4, which is not correct, right. So, that is not satisfying, that is not satisfying. Okay. So, what should we do? We need to do the trial 2, we need to go for the trial 2. So, when you do, we need to do the trial 2, perhaps I will use the same space. Okay. Trial 2. We did trial 1 is not matching. Now, let us use what is speed we are going to use it? 125 rpm. Can we choose 125 rpm? So, n input 125 rpm. Again, we have to check this I max and I minimum. So, when you want a high max, right. So, I have 250 rpm by 125 rpm, which give me 2 is less than or equal to 2, okay, which is correct. I minimum, the ratio 31.5 divided by 125. So, when you have 31.5 and 125, I should get greater than or equal to 1/4. I am getting 0.252, which is greater than 1/4. So, can we choose 125 as the input speed? Okay, we can choose. Yeah. So, from here, so the input speed of third stage n input of third stage is, okay, 125 rpm, 125 rpm, okay, that is fixed. Yeah. So, in that case we can mark one point here, right. So, that is done, that is done, okay. Yes. So, you can see that we have marked 31.5 and 250 rpm and 125 rpm, okay, fine. So, is it enough now? What is the structural formula again? 2 of 1, 3 of 2, okay, and 2 of 6, 2 of 6, okay. Now, so since we are starting from the last stage, move on to the first stage. Let's find out what, okay. So now we know that, but prior to the second stage, before going to second stage, my third stage should have how many speed? Tell me how many speed I should have a input speed? 6 input speed, right? Right. That is given as 6 input speed. Okay, fine. What is the difference between the second stage and the third stage? Yeah. Right. So I need to have in the second this is my third stage, this is my third stage, this is my second stage, and this is my the first stage, okay. Yeah, it's okay. Yeah. So how do I move on now? How do I move on? Right. Remember, so there is a overlap. Even though this is this third stage, right? Third stage input will be output of your second stage, right? So if you look at 3 of 2, what does it indicate? 3 of 2, what does it indicate? You have a 2 input speed, right? You need to have 2 input speed and 3 output speeds. That means I need to have a, by end of the second stage, I need to have 3 output speed, isn't it? 3 output. So again, the one more information I would like to say is 3 of 2, right? This is your input and this is your output. So another information what I said, for given one input, right, the output will have 3 and that should placed with the difference of 2 step ratio, the difference of 2 step ratio. So tell me what is 2 step ratio? So this is my lowest one. So can I, is it possible for me to move down? No, because already I fixed n minimum 31.5 of the gearbox. So I can't. Only way is I had to move up. So then if I follow this two step away, the next speed would be like this, 250 rpm. The other one would be 500 rpm. Okay. So now we will go for a stage 2 aspect. This is what happened. Now you know that, right? So now when you go for stage 2, what information do we have from stage 2? Stage 2 again, 2 of 1, 3 of 2 and 2 of 6, right. We will choose this one, stage 2. Okay. So from this, right, I can only move up, I can't go down because I have already fixed the lowest speed or the minimum speed. Tell me what is the minimum speed from ray diagram I am getting for second stage, the minimum speed and the maximum speed. The minimum should be 125 rpm, right. The minimum is 125 rpm and the maximum is 500 rpm. So we have to repeat the procedure which we did it for the third stage to find out what is the appropriate input speed for the given n minimum n max in the second stage aspect. Okay. So, we had to find out input speed for this. Okay. So, again we can, the variations given starting from 125 rpm to up to 500 rpm can be used as a input speed for stage 2. Okay. So, yeah, we will do similar to the trial 1, trial 2 like that what we did. Okay. So, can we choose 355 rpm? Let us choose, let use n input as a 355 rpm. I will start from the top. Okay. Now, I need to find out this is trial 1, trial 1. Okay. So, I max your n max n input. Okay. What is n max here? 500 rpm, 355, right. So, that should give me 1.4 which is less than 2. Then your gear ratio, minimum gear ratio I mini, n mini and minimum speed and input speed. So, minimum is 125 rpm, right. Minimum is 125 rpm and this should be 355. So, okay, we got 355. So, it is giving you a 0.35 which is greater than 1/4. Okay. Fine. So, I think both are satisfying, am I right? Both are satisfying. Okay. But we will do one more trial to understand. So, let us choose a trial 2. N input I will choose as a 500 rpm. Okay. I can go down also, but let me choose 500 rpm. Okay. Again I max it is a right, I max 500 by 500, right, 500 by 500, that should give me 1 less than or equal to 2. Fine. N minimum I mini will be 125 and 500. That give me precisely 1.4 of given 1.4, both are okay. If we have two scenario, in trial 1 we got I max 1.4 ratio which is less than 2, correct, and I mini is 0.35 which is greater than 1.4, correct, that is also fine. In trial 2 for given speed 500 rpm, the I max gear ratio is given 1 which is perfectly alright, is less than 2, but I minimum, right, I mini is same exactly 1/4 of the your things. So, if you look at closely, this is almost at the extreme end, right, 1/4, we said 1/4 greater than 1/4, but exactly 1/4, but we have option which is slightly more than the 1.4. So, in design you want to use extreme condition, you want to be move away from the extreme condition for safer aspect. You have to move away from the extreme condition, right, it is in the borderline, so that is risky, right, still satisfied. So, design as a multiple solution, please understand, design you do not get one particular solution, you will get multiple solution based on the what is your need, that is a fundamental aspect. So, we can choose right both ways 0.357 or 0.25 also, but would be nice to have 355 rpm, that will be little more even safer. When the option is given, better to choose. So, I would choose the next input rpm of stage 2 as 355 rpm. rather than the 500 rpm. So, this would be your 350 rpm as an input to stage 2, right. So, 350 given. So, again as given the structural formula, right, how many input input I need for stage 2 and right, and how many output I need for stage 1. How many output I need for stage 1? 2, right, 2. Okay. At the same time, the spacing between two output speed will be 1 step, as a 1 step. If you look at, that's what happened. That's what happened. Okay. So, now we know that. So, now we are move on to the stage 1, 2 of 1, 3 of 2 and 2 of 6. So, this is one we are focusing now. So, from this if you observe carefully, your minimum speed, what is it? Minimum 355 rpm, maximum 500 rpm. Okay. The question is, do we need to follow I max and I minimum for the first stage? No need. Do we need to follow? You don't need, because that is valid for the other than the first stage. Okay. So, in that case, so straight away, because it is a speed reduction, remember the motor input speed was given 1500 rpm, right. So, 1500 rpm. So, we know that is given the, but we are only focusing about the what we are constructing, that is a thing. So, from here we can either choose either 710 or 1000 for that does not matter. So, I choose as a 1000 as a input speed for stage 1. So, now what we have done, we made the basic skeleton. This is called skeleton. This is skeleton of ray diagram. With that we are going to fill the other speeds also. How are we going to fill the other speeds? Because we know the step ratio, as long as you follow the parallel lines connecting one speed to another speed, right, that will fill automatically the ray diagram. You can see that. So, I am naming A, B, C, D, E, F, G and H. So, this is the skeleton ray diagram, right. Now, from we do how to construct it. So, that is the your input speed split into 2 output speed. Remember, 2 output 1 input, that is the first stage. Now, second stage, right, second stage 3 of 2, right, 3 of 2, that means for given 1 input speed I should have a 3 output speeds. So, are you getting 3 output speeds? Okay. So, we are, so far we did a connection, now we are connecting them through the rays, that is the reason it is called as a ray diagram. Okay. Now, what is that next one? 2 of 6, that means for 1 input speed I should have a 2 output speeds. Okay. It is done now, right. So, now still remaining is there. What are the remaining is there? This has to be filled and this has to be filled, right. Once this filled, then you have another one to branch out. This will branch out as a 3 output speed. Your point G will branch out 3 output speed. Each output speed again branch out to 2 output speed in stage 3. Yeah. Look at this. So, I am doing a parallel lines because I am following the step ratio. So, between, so look at this, this is 250 rpm, this is 125, fine. So, but the output has to be 63 to stage 3, again it should have a 6 steps difference. You can see that from 63 to 500, 90, 125, 180, 250, 355, 500, which is 6 step ratio away. Okay. Similarly, for E also, 125 is the my output speed. So, this the next speed would be 6 steps away, 180, 250, 355, 500, 710 and 1000. Okay. So, now we in fact we did it. Now, we will move on to the G also. I am putting into different colors to differentiate. From G, I should expect 3 output speed. Again, as to maintain the step ratio 1. Right. Look at, they are having parallel lines. This parallel line and this is the parallel line. Okay. Similarly, it extend it. All are will follow the structural formula without any confusion. Okay. Now can you see that? Can you see? Did we fill completely the ray diagram? Did we arrived all the 12 speeds? Look at 31.5, 45, 63, 90, 125, 180, 250 and 355, 500, 710, 1000 and 1410. So, we have filled completely the 12 speed distributed in a proper structural formula. Not only that, and also using optimum, the I max, the gear ratio, maximum gear ratio, minimum gear ratio and the n max greater than equal to n input greater than your n minimum. With that, we are able to construct the ray diagram. Okay. I think I will stop now. The next class we will discuss about using this ray diagram, how are we find out construct a kinematic diagram which talk about the gear arrangement. Okay. So, these are the things we are going to discuss. We will continue the problem in the next class also. Thank you.